lesson or topic 2-3 is what we're looking at today. And example 1 once again is on the realized site, so we're going to go through examples 2 and 3 together today. As we look at these samples, we're dealing with proportions and trying to understand if two different increments are proportional. And so looking at a comparison of these things. So in this question, we see 3 squares, one that's 2 inches, one that's 3 inches, one that's 4 inches. And so the question is the area proportional to the side length? So to do this, we're going to set up a table, as you can see here. And so as we draw out this table, we're going to put our increments. So, right, making correct labels is important so that everything lines up so that our proportions are lining up the same values, right? Our ratios are lining up the same values. So as we look at this, we have length of sides, right? So we have 2, 3, 4. And then we find the area. Area, of course, is, since they're squares, it's going to be the side squared. So 2 squared is 4, 3 squared is 9, and 4 squared is 16. Now at this time, now we want to look for the ratio, the comparison, which is going to be area. In this case, it's going to be area divided by side length. Right? And so with that, we have 4 divided by 2, or 2 over 1. 9 divided by 3, which is 3 over 1, and 16 divided by 4, which is 4 over 1. So we've gathered that data so far. Now, the question though asked is, are they proportional? Proportional would mean that they would have to be equal. And very quickly you're going to notice that obviously 2 over 1 is not equal to 3 over 1, which is also not equal to 4 over 1. And so we would say in the end that the ratio of area divided by side length is not equivalent, and so in that case it's not proportional. So that information is given to us. Go ahead and use this table and set up a similar problem as you work with perimeter and the side length as it deals with hexagons, right? So you have your first 2 columns developed, you'll have to figure out the ratio side of it and then compare those ratios. All right, then example 3 starts us off with our definition of a proportion, right? An equation that represents equal ratios, so that equal comparison. And we can see on the right that we have a table that's been developed that shows us the beats of the wings of a hummingbird in these different time increments. So in 2 seconds it's that, 7, right? And it continues on. Right? So what they're asking for is, because it is proportional, that means that ratio that is going to continue on throughout all increments. It's not going to change. Like example 2, there was a change, right? As there was a different proportional relationship between the side and the area. So they weren't proportional, right? There was a different ratio of ideas. So what we're looking at here on this one is we're saying it is constant. So because it's constant, how can we use that information to figure out what 60 seconds is going to be? And so what we're going to do is we're going to follow these steps. The first thing we want to do is make sure that they actually are proportional. And to do that, you're going to simplify these by dividing them out. Right? If you could see, as you divide them out or as you simplify them, that 160 divided by 2 is equal to 80, just like, right, 56 divided by 7 or 560 divided by 7 is 80, and just like 800 divided by 10 is 80. So we can verify that they are proportional. Right? We do need to analyze tables to make sure that they are proportional before we just jump in and say, okay, they are proportional. So now that we've proven that they are proportional, we can move on to step 2. Because they're proportion, we now know what the proportion is. We know the ratio that we can use, and that ratio is 80 over 1. So 80 beats in 1 second. Now since we've done that, we can now create what's called an equivalent fraction. And since we're looking for 60 seconds, we can use that information to help us understand this. And so by using this information, we can see that 80 over 1 should be equal to y, that's our unknown, and 60. Right? That's our 60 seconds. So 1 second to 60 seconds, and 80 beats to our unknown idea. Okay? So that's what we're working with here. And this line here just reminds us of the proportional side of this problem. So to solve this problem, what we're seeing here is that they have decided to eliminate the denominator on this side. So to eliminate the denominator on this side, I'm going to have to multiply. Technically, it's kind of like y as a whole number over 1 over 60. So 1 over 60, if we want to eliminate that 60, we got to multiply by its reciprocal, which would be 60. So 60 times 1 over 60 is going to eliminate that. But if I do it to this side, I have to do it to this side also. And so we have 80 divided by 1 times 60. And 80 times 60, of course, gives us this answer right here. Another technique that you could use here is what we would call cross multiply and divide. So I would take 80, multiply by the denominator here, and then divide by my denominator on this side. Right? So 80 times 60, which would give us 4,800, and then divide by the 1 here. Okay? Alright, if that representation didn't make much sense to you, then write a question right now in your notebook saying, show us how to do that in class, and I will gladly do that for you. Alright? Alright, but make sure you ask that question. Okay, then from here we get our final answer, and we can then put proper labels, different things like that for this problem. Try to hide that menu. Alright, moving on. Here is your chance now, right? Different scenario, but we're going to use the similar setup that we've been working with so far. Set up our ratio, look for a proportion, and then use that proportion to solve an answer. Alright, that's it for topic 2-3.